All right, so the instructions say to, let's let that load up here. That's off screen, but it does say, why did that happen? It does say to solve the equation by cross multiplying. There is something you should do before you cross multiply, and that is to set both of the bottoms not equal to 0, which is a little weird. You'll see why in a moment. Now, the reason is you are never allowed to divide by 0. It's like one of the worst things you can do in math.
Yeah.
And by setting these not equal to 0 and then solving for x, we're going to divide by 2 on both sides. We are saying now that x cannot be 0. So if you get 0 as an answer, that cannot be the case. X cannot be 0, is not, cannot, will not, all that stuff. So then on the right here, subtract 6. X cannot be -6. Okay, so these are the excluded values.
Uh-huh.
Okay, and the way you just sort of tuck this off to the side, and you know, full disclosure, I'll probably forget to do this at some point tonight, which means you probably, you know, as a student, you probably will as well. This is really important to do this first, but it's not mandatory. It is better if you do it first. So the idea is like you're going to solve this thing, and if your answers matches 0 or -6, you have to know to throw it out. All right. So now, what does this mean by cross multiplying? They sometimes call this a butterfly.
Yeah.
And whatever you want to do, I think circling it's good. It doesn't matter where you put them, whether it's left or the right side, but I'm going to go 4 times quantity x plus 6 equals 5 times 2x. So you've converted your problem into one like this. Okay, so now you solve this the way you solve something much earlier in the course. You're going to distribute that 4 to both terms. So it ends up being 4x plus 24 equals 10x. From here, you move the 4x to the smaller, from the smaller to the larger. That's 24 equals 6x. And then you divide both sides by 6, so x equals 4.
Yeah.
Now, you might think, well, why couldn't I have just done that, gotten my answer? You could, you really could, like, but it's kind of like, are you the type that, you know, waits until something breaks, or are you more of the type to, like, you know, be on top of stuff and maintenance kind of thing? It's kind of almost like a personality thing where, you know, I like to always kind of assess where it could go wrong and then hope it doesn't. Some people just do it and they hope that it doesn't become excluded.
Yeah.
So we'll you know, and the other thing is, like, until you see an exception, until you see this not work, you're like, why would I ever do that? And that's reasonable, it really is. So again, like, I would tell you strongly to, because it makes, in future problem sets, it really will matter. I would set x minus 1 not equal to 0 and x plus 1 not equal to 0. So x cannot be 1 and x cannot be -1. In terms of the cross multiplication, believe it or not, some schools don't teach this. They really are anti cross multiplication, but it's really a good thing to do here. I like it a lot. 9 times x minus 1. So I'd like you to try solving it from here. Let me know what you come up with.
Okay. I got x equals 5.
Okay. Now, another kind of approach here, since let's just assume you didn't do this off to the right, is you can actually check your answer. And that's what we're going to do now. So your answer is 5. Is 6 over 5 minus 1 equal to 9 over 5 plus 1? Okay. So is 6 over 4 the same as 9 over 6? And if you're not sure, you have to reduce both sides. So like 6/4, you can divide both of them by 2. So that's 3/2. On the right, you can divide both of these by 3. So your answer is correct.
Yes.
You may even see that. It may even say on the exam, or I'm sorry, on the quiz or something, check your work. Some teachers are big on that. All right. So they do get more complicated. I think for now we're going to stop doing the excluded values, and we'll just jump right into solving it. So again, there's implied parentheses everywhere that I'm drawing it. And even in the X, there's these implied parentheses. You don't need it when it's a single term, but for sure when there's two, you just don't want to write it in such a way where you don't remember that you have to distribute to both. Okay, so this is the cross multiply step here. And this is where it's like, well, this is why you learned FOIL. This is why you learned how to multiply in. That X gets given to both, so it's X squared minus X. And then this one, will you FOIL this one on the right for me, please?
Yes. Um, 2x squared minus 3x minus 35.
Just checking. Yeah, minus 3x minus 35. That looks good. Okay. You generally move from the smaller to the larger. So we're going to subtract that x squared. And then we're going to add x because we want everything on the right now. So it ends up being x squared minus 2x minus 35. Okay. And this is why you learned all this stuff in previous chapter, because you're going to need it now. Will you FOIL that, not FOIL that, will you factor that for us, please?
Yes.
Two numbers that multiply to minus 35, but add up to -2.
It'd be -7 and +5.
Very good. And then really this is set equal to 0. So you set both x terms equal to 0. Okay, so x would be 7 and x would be -5.
Yes.
All right, now what is the challenge with checking the answers this time, in your opinion?
Well, you have to divide and set them equal to each other.
So there's division, there's fractions on both sides. There's also, you got to substitute the numbers in two places. You also have to do it for both. Like you have to do it for once for 7 and then once for -5. While you can check, it is cumbersome. It's a lot of effort to check. So keep that in mind. And that's yet another reason why to write out the exclusions. Like if you write out 2x plus 7 cannot be 0 and x minus 1 cannot be 0, the bottoms, and you end up getting down here, you get x cannot be -7/2, x cannot be 1. As long as you've solved it correctly, and you have, then you know your answers are right.
Okay.
But if you don't do this, then you really should check. I guess when you go to class tomorrow or next time you see your teacher, look for this, see if this is brought up, or see if at the end of the problem, if you're supposed to check. That would be a good, question to ask to show that, you're engaged in what's going on there.
Yeah.
All right, so let's look at number 9, have you do a bit more of the work on this one. But for number 9, in terms of like your exclusions, you do set x plus 2 not equal to 0, the left bottom. The right bottom does not have an x, so you don't have to look for an exclusion. But what I'd like you to do is take that 2, multiply it by the x squared minus 3, x plus 2 times x minus 3. And let's get that far. Go ahead and work that out. We'll see what you come up with when you
Okay.
cross multiply.
I got 2x squared minus 6 equals x squared minus x minus 6.
Good. Okay, so now which way should you move terms? And there's not like a wrong answer. You just have to have good justification for which way you're going.
I think I'd move the x squared to the left, like I'd subtract it.
Yeah, I agree. And then we're going to add x, which there's nothing to add it to, so you just kind of put that offside, add 6. So if it's too much, you don't have to do it all at once, but you do eventually have to move everything off to the side here.
Yes, I got that too.
All right, so this is not a hard problem, but if you haven't seen this in a while, you're like may not know what to do. Do you have any idea how to proceed from here?
I mean, you would factor, but I don't know how you would factor this.
So it is a GCF. There's something that is common to both.
X.
X, yeah,
I can take an x out.
that's right. What goes inside parentheses?
X plus 1.
X plus 1. Now you said both of these equal to 0, x equals 0, and x plus 1 equal to 0.
Okay.
And so you got your two answers there. So I'd like you to try either 6 or 8, your choice. Just pick one of those and work it from start to finish. And ask if you have any questions, please ask
Okay.
along the way. Which one do you think you want to do, 6 or 8?
I can do 6.
Okay. All right, so give that a go.
I got x equals 2 for number 6.
Wow, that was fast. Did you did you photomath that? That was really good.
No, that one just came a little bit easier than the other
Yeah.
one.
Yeah, there was no foiling on this one. No, it is x equals 2. That was really good.
Yeah.
All right, let's move to the next grouping because there is quite a bit more to do here, but that was a good start for this to all right. 19.
Okay.
Okay, so this is where the bulk of your like problems you'll see on the test or quiz will be. So this is good that we've got a lot of time here to work these out. You still do exactly what I mentioned before. So you set anything in the bottom that is an x term not equal to 0. So we're just setting that one right there. All right. So basically this is just saying like if you get 0, there's a problem. Hopefully we'll see an example like that coming up and we can talk about it. But in terms of what you do next, we're going to write the 2 over 1 as a fraction. So it's 3/2 plus 1 over x equals 2 over 1. And you look at the 3 bottoms. So you got 2, x, and 1. and you want to find the least common multiple of those. So for refresher, you look at the numbers first. Between 2 and 1, the least common multiple is 2. Since there's no other x's, you have to choose the x. So your goal here is to turn each of the bottoms into a 2x. I'm just creating some space here because we're going to end up multiplying. So the way that I like to talk through this is to ask yourself, what is the on the left here for this 3/2, what is the 2 missing so that it gets a 2x? What would it, an x? Yes, you multiply the top and bottom by x. And that puts 3x down here. What is this x missing to get to 2x?
A 2.
Times 2 times 2. So there's a 2 there. What is this 1 missing to get to 2x?
It's missing 2x.
So you multiply top and bottom by 2x equals 4x.
Yes.
Okay. Now, this is very important right here, is that you have to recognize that all the bottoms are the same. Right? All the fractions are the same denominator. When that's the case, you can disregard the denominator and just look at the numerator.
Right.
That's key. Like if you can't get there, you have no way to go forward in these problems.
Yeah.
Okay, but now it's not bad. Now this is a problem that you saw months ago, or last year or 2 years ago. This is totally doable. So you subtract 3x from both sides, and you get x equals 2. And again, you can check, like you can go back and you can put that in here and check, or you compare it to your excluded values and you're done. Okay. So he might think, well, I got it. This, no big deal. This LCM or LCD, sorry, they do LCD. That's wrong letter. That's really the heart of this, is figuring out the LCD. So that's really where we're going to spend the bulk of our time, because it gets way more difficult in 21. Any questions though before we move on from this?
No, I think I'm good.
All right. So you should always write everything as a fraction. So you got 4/1 takes care of that. And now you're looking at x minus 4, 1, and x, and you're trying to find the LCD between them. Okay. Now, what some students say, or they somehow believe, is like, well, I'll just multiply them all together. And that works sometimes. Okay. It does work in this one. Like, because there's a 1 there, multiplying it by 1 and then by x minus 4, like that is your LCD. Okay, we'll talk a little bit more about that here in a bit, but you keep it in factored form. So you keep it as x times x minus 4, x times x minus 4. You do not multiply. Okay. So now you're trying to figure out, well, what are they missing? Like, what is that first term missing to get to so that the bottom is now x times x minus 4. Like the top is x minus 3, bottom is x minus 4. What is the bottom missing?
An x.
So you multiply the top by x. And it's just the top that comes down because you've already got the bottom. So it's x times x minus 3. Okay, now we've got this 4/1. The 1 needs to become an x times x minus 4. So it's missing everything. You're going to multiply by x times x minus 4, x times x minus 4. Is that okay?
Yes.
Now, this is about the point where I always tell students there's a lot of writing in these problems, perhaps the most you've done up till now. And it doesn't get better. The problems get longer, more writing. So leave yourself plenty of room when you're working on these. The last one here, the x is missing an x minus 4. So it's 3x times x minus 4, like that. So it looks really bad, but the bottoms are now the same.
Right.
So now you just focus on the top. Focus on the top. So this becomes x times x minus 3 plus 4x times x minus 4 equals 3x times x minus 4, like that. And from here, you're solving, and it's work, but it's very much something you're supposed to already know how to do. You distribute the x into both. X squared minus 3x, 4x squared minus 16x, 3x squared minus 12x. And very important that you distribute to everything.
Okay, it's a lot of writing to
Yes,
catch up.
yes.
Okay.
Okay, now we're just going to combine like terms. So like on the left, there's an x squared and an x squared. That's 5x squared minus 19x. And uh-oh, did this really not? This one doesn't have a nice solution. That's okay. Let me just quickly check that the solution is what I think it's going to be, or I got to go back and check for an error. Yeah, okay, that's going to work out all right. Okay, so now we move the 3x squared over. Okay, add the 12x. So that's 2x squared minus 7x equals 0. And what do you do from here to solve this? This is kind of like the last problem.
So you can take an x out from that.
That's right. So it becomes x times 2x minus 7 equals 0. So x equals 0. 2x minus 7 equals 0. So the one on the right here is 7 halves. Okay. Now, this is actually, of course, it's the one problem that I don't draw the exclusions for. There is a problem here with this solution. So I think that's one of the frustrating things about this. It's like, well, you can get all the way to the end and you still don't know if you're done because you have to check your answers. So if you go back to the beginning, and I have the advantage here of, I guess, I can just snip this in here again and look at it. What is the problem with x being 0?
Oh, because you're going to be dividing by 0 then.
Yeah. And that's why you're supposed to set from the beginning. You're supposed to set the bottoms not equal to 0, because that tells you your excluded values. It says, well, x can't be 0, x can't be 4. And then if you get 0, you just know to cross it out. And there's no way to know until you're all the way done with that.
Yeah.
Any questions on it, or any thoughts, things you want clarity on?
So if x equals 0, and so like there was one other one we had where x equals 0. I think it was.
It's okay if it's 0. It's just you can't divide by 0.
Okay, so it's just hard to check.
Yeah, it is hard to check. These are really hard to check. So that's why you you want to determine what's excluded first before you solve it. It's kind of like checking for, before you go on a road trip, you look to see if there's construction or toll roads or anything like that. Way when you get there, you're not surprised.
Yeah.
Nothing worse than that. Okay, so let me do a better job on this one of starting out by saying, okay, let's exclude the bottoms. X plus 4 cannot be 0. X minus 1 cannot be 0. So X cannot be -4. X cannot be 1.
Yeah.
All right, now again, that's really 4 over 1. It's important to look at that.
Mm-hmm.
So you're trying to find the LCD between the X plus 4 and the X minus 1, but they're treated as binomials. So in this case, you're going to just multiply them together. So like your LCD is the product of them. The X plus 4 times X minus 1. So X plus 4, X minus 1, 6X. So hopefully by now you can see that you just show what's missing. X minus 1 plus 4. The 4 is missing everything. So you got to multiply the top and bottom by everything. And then the last one there, it's just missing the X plus 4. So you have to multiply the top by X plus 4.
Lots of writing.
Yes, yes. Yeah, it's yeah, you're showing your work here. You're showing
Yeah.
how you're getting there. So now we just look at the top. 6X times X minus 1 plus 4 times X plus 4, X minus 1, 2X plus 2 times X plus 4. So you just a lot of multiplying, foiling. For the FOIL here, like one shortcut is to FOIL, so it's X times X, X squared, and then multiply by 4 like each time. So now when you do the outer, like X times minus 1 minus X, 4 times X is 4X. So minus 1X and 4X add up to 3X. Multiply by the 4, that's plus 12X. 4 times minus 1 is minus 4, and then multiply by the 4. And then you can FOIL the last there.
Yeah, that's what I got to.
So anything you can do to minimize your writing is really important here without avoiding missing something. The most errors occur here is just transcription line to line, or forgetting to distribute in, or sign error. So on the left here, it's 10X squared. Let's see here, plus 6X minus 16. And then you can start moving things. You get 8X squared minus 4X minus 24 equals 0.
Is this where you multiply the 8 by the 24?
You should always do a GCF first because it reduces the complexity of the problem. So there's a 4 that goes into all of these.
Yeah.
And then this is where you can do what you're about to say. But rather than multiplying 8 times 24, which is quite large,
Right.
2 times minus 6 is much more manageable.
That'd be 12 or -12.
Yes, you need two numbers that multiply to -12, but add up to -1.
So it would be -4 and 3.
That's right. So it becomes 2x squared minus 4x plus 3x minus 6. And you're just splitting it. You're just splitting it apart. You still got to do the grouping now.
Right.
So 2x goes into both. That becomes x minus 2. You put x minus 2 here, and you hope and pray, you hope that it works out, and it does. And then with grouping, again, you have to factor out the x minus 2 from both. So it's like from, I don't know, from this line up here, like that was a problem you were doing in the last chapter. And now you've got to replicate it in this chapter along with other stuff.
Right.
So your speed of your handwriting, your speed of your calculations really matters here. Set them both equal to 0. And you get x equals 2. X equals minus 3/2. And I'll just bring it down off to the side here. We said that x cannot be -4 or +1. So we feel pretty good about these.
Yes.
So what do you think? I mean, it started way up here.
I know.
I don't know how much, I mean, I don't know if it's half a page or I don't know if you, depends how big you write. Like these are complicated.
Yeah, it was like about half a page. There was like, yeah. I tried to write small because I'm using like front and back for my homework, so I'm like trying to write pretty small.
Right. All right. So let's because it is important that, you know, we from last semester, it's really good for you to try a couple of problems here. 29 is the most comparable to what we've been doing. So I'd like you to try this problem. Ask me questions along the way.
So I don't know if you were trying to talk during that. I just couldn't hear you.
I didn't. I was
Okay.
I was debating whether I should put this up or not. And it's already up there. But I was hoping, the goal here is for you to try to navigate through one of these. Is it clear that the LCD is the product of x and x plus 3? That 1 doesn't really contribute anything to it.
Yeah.
Okay.
Okay, so now you just distribute on the top.
Yes. Now that negative goes to the 2x, so it's -2x times x times the 3 there.
So it'd be -2x squared minus 6x. And then the first one would be 5x plus 15.
Okay. So this is maybe it's a little odd when the x squared is negative. So you can move everything to the right if you prefer. Like I would recommend getting rid of the negative by doing that. It's up to you though.
Yeah, we can do that.
So just for some clarity, it's 2x squared minus x plus 15 equals 2x. And then you will move everything right. So you're gonna end up getting 2x squared. When you add x, it's going to be 3x. Subtract 15.
It would be three. Oh, wait. Oh, okay. I see what you did. Okay. And then you factor.
Yeah, so try factoring this one on your own. See if you can.
So this one there's no GCF, so you have to multiply the 2x to
2
the
times,
negative
yeah,
15.
just like we did up above. It's a grouping problem.
So it would be what multiplies to 30 or negative 30 that adds to 3.
Yep, two numbers that multiply to negative 30, but they have to add to 3.
It would be 10 and negative 7.
So those don't work here.
Oh my gosh, no. I was literally just thinking of the bottom. I didn't
But
even think about negative.
I'm also bothered here that like this does not work as is. Let me check here. Maybe I missed something here. X plus 3, x plus 3, 2x, x plus 3, 2x. Okay. Minus 2x squared, minus 6x. That's a minus x. 3 and 5. So this one does look like it's quadratic formula. Let me just confirm that here. And sometimes it's, this is where you go to the back of your book and you look and say, well, does this even work out?
Yeah.
Of course, I picked the one problem to have you do that doesn't work out nicely. Yeah, this one's quadratic formula. So that's another good question for your instructor to ask is like, will we be expected to use quadratic formula to solve these? And because this one's much harder. I mean, it's basically a brand new problem from here. We should go through it real quick, just as a reminder. A is 2, B is 3, C is minus 15. So X is minus B plus or minus the square root of B squared minus 4AC all over 2A. Got to know the formula. That's really what I meant. Like, will you be expected to know this? Will there be any problems like that? That'd be on my mind. So it's minus 3 plus or minus the square root of 3 squared minus 4 times 2 times minus 15 all over 2 times 2. And it's the part inside the root that's really the challenge. It's
Yeah.
the negatives here make the positives. So it's 2 times 15 is 30, 4 times 30 is 130, 9 plus 30 is 139. So it's minus 3 plus or minus the square root of 139 over 4. Sorry, 29.
I was gonna say
29, yeah. Yeah, 29. And that's it. That's your answer. It does not reduce from there.
Oh yeah.
It's definitely not excluded, but it's not good either. And every once in a while I put on something, I'm like, this just doesn't match. And that's how this looks to me. This just looks hideous. So it's all
Yeah,
right.
I hate those. The end's really weird.
Yeah. All right. So let's look at 25 next. Did we do 23?
We did 23.
Okay, so we'll do 25. All right, so this one's kind of a variation on what we've been doing. because now there's like a quadratic in the bottom. So you do factor the denominators first before you try to find the GCF. So like in this case, it's x times x minus 3. And just to save space, I like to write that right underneath there and just kind of squiggle it out, because I don't want to have to rewrite the whole thing again. It's awful. So now this is kind of the first one where it maybe the GCF isn't as clear, but you've got an x minus 3, an x minus 3, and an x. And you got to find, sorry, the LCD, not GCF, LCD. So do you see that they like two of them have an x minus 3 and two of them have an x?
Yeah.
So the idea is that you want to get it so that they're all matching and can get to something that does match. Like they're always sort of increasing. So x times x minus 3 is your LCD. You know, these both have this, they both have this. So that, and that what's nice is that first term already has it. X times x minus 3. Like it's already good. You don't have to multiply anything
Right.
there. But the x minus 3 under the 6, well, what is it missing?
An x.
So you got to go x and x. And what is the x missing?
X minus 3.
X minus 3. Okay. So why don't you take it from here? Do as much as you can to work this out and let me know what you come up with.
I got negative x equals negative, what's that? 33.
So
Yeah.
the negative 6x though is negative, like it's that goes with it. So you're adding 6x to both sides, I guess is what I was trying to get you to. Because I heard negative x.
Oh, that's where I messed up. I
Yeah.
accidentally added 5x, which you can't do. Add 6, or I should, yeah. 33 equals 11x. So then x equals 3.
X equals 3. Good. Okay, so we'll do what we can on 27. Oh, sorry. No, we're not done with this one. So again, I keep forgetting to do this. I mentioned I would do that. We didn't exclude. We didn't say that x cannot be 0 and x minus 3 cannot be 0. Because when you get x equals 3, what happens when you put it into this one right here? 3 minus 3.
Sorry, say that again.
What happens when you put 3 in to 3 minus 3? Your solution x equals 3 back.
Oh, it's just going to be 0. And you can't.
Yeah, and you that's why yeah, you really should exclude things from the beginning. That way you know, oh, this actually has no solution.
Oh, okay.
And if it's like frustrating because you're like, well, wait, I just did all the work, I got a number. What you're doing here is it's like a manipulation of the like what I call the space of the problem.
Right.
You know, think of it as like there's things that work. There's customs we have here in this country, and then there's customs in other countries. And like just because something works here doesn't mean it's going to work there.
Right.
You know, the space of the problem is being changed. All right, so let's see really quickly we can get 27 knocked out here. You can probably see that the LCD is going to be the x times x plus 6. It's gonna, because they're paired up here like that. So you're gonna have X and X. Two X plus one, X plus 6 times X. Right. And so from here, you gotta multiply the top X squared plus X plus 6 equals 2X plus 1. And then you're just combining like terms. So X squared plus 2X plus 6. Subtract the 2X from both sides, subtract the 1 from both sides. X squared plus 5 equals 0. And this also has no solution. And if you're like, well, why is that? I mean, it looks kind of okay. Well, when you subtract 5 from both sides, you're now taking the square root of a negative number. No real solution, we should say. So, like it's possible that within all these problems, you could see something you've already looked at. And that's another one of those to ask your instructor, well, like, is the, should I say it's plus or minus 5i? Should I use the quadratic formula? Should I check from the beginning whether the solutions, exclude the numbers or not? Things like that. That would be, that's a good way to know if you're kind of on. They'll appreciate that you're kind of thinking about these things. Maybe they haven't thought about them yet, so you would, but that'll